Okay, so today we're going to be going over a little bit of the sensors and again some of our more basic movement. So we have opened up RobotC. Let's start out by opening up a new file, right? And let's call this Slalom challenge. I think that's how you pronounce it. So basically, if you see, we're going to be doing one of the line follower challenges. Let me just call this I'll just call this line follower, make it simple. But a RobotC virtual world has a different name for it, so I'll just call it line follower challenge. So it opens up the curriculum companion and we'll just see the layout of this challenge. So it's under sensing. It's called Slalom. I think it has something to do with skiing. Let me search it up. We'll just say slalom definition. Yep, so it's a ski race down the winding course marked by flags or poles. So right now you can see the layout of this. We're just supposed to make our robot follow this course, this winding course, and not hit any of those little like studs, those little cups. I think that's what they are. So that's the goal, and basically to do that, it's going to be much easier to use a line follower and a sensor to follow this line as opposed to trying to manually code as we've done in the past. So let's start out by setting up our robot. So for this challenge, we're going to use the swerve bot. So let's first make sure obviously that our compiler target is for virtual worlds. And let's set our robot. So click on this, motors and sensor setup, standard model, configuration, and we're going to choose swerve bot. And if we again go back to motor and sensor setup, we'll see that the left line follower is set up right here. And that's the one that we're going to be using. We're going to be using the left line follower. So it gives us this configuration for the swerve bot, right? And let's just start out by saying while true, we want this code to run forever. And we say if, or we'll just say while true, let's just say motor. We'll start out by just making sure. We'll just say 127 and then motor left motor is equal to 127. So I just want to see how the codes are going to be run so far, make sure everything's in order. Let me compile. And something helpful that I found is if you click fix formatting, it will basically just reset the formatting for our code, make sure that it's a little easier to read. So that's just that one that says fix formatting. So now let's just go ahead, compile and download, and just test out our course, test out our program, make sure all the simple stuff is working. Sensing. So obviously right now our code will just go forward forever, right? So it's just gonna go forward and we're gonna have to try to move out of that cup's way. So now what we'll try to do is let's use an if statement. And we're going to use the left line follower sensor. So sensor value, left line follower. And we'll say that it's less than 2000. And basically what the number 2000 means is the sensor is going to return a value between 0 and 4095, in which 4095 is the darkest reading it has and 0 is the lightest. So this number 2000 is just supposed to help us differentiate between darker and lighter spots on the map. In this case, the line is what we're trying to follow. So we're saying sensor value left line follower should be less than 2000. So it's going to be, if it's on the lighter side, we're just going to ask it to move. Okay, so right now, if we click robot and make sure that okay, first go ahead and compile the program, and to see the information that the sensors are giving off, let me download program, and click robot debugger windows, and make sure that sensors is selected, because this gives us information for the sensors. So log in, sensing, make sure robot selected, sensing, and we'll see right now that the left line follower is sensing 701, so that's less than 2000, so it should go forward until it senses something different. Okay, it didn't sense the black line. Maybe go a little slower, we'll be able to sense it. Maybe that was too fast for it. So let me just download the robot. Try again. Hopefully so. Still didn't notice it. Okay. I guess that's fine. We'll just let's try to make it so that it notices it. Let's make it turn, I guess. So we'll make it turn to the left. So let's make the left motor go a little faster. We'll just say the left motor is going at 100. Download to robot. Try again. Oh, it's still not noticing. It's odd. Okay. Saying less than 2000. So we've made the robot turn, and we're saying if, so let's just make an else. And so since it's not able to, so we're going to say else, right, if else, and we say motor right motor is equal to 127, and motor left motor is equal to, let's just say 60, or we'll just say 160. So see if it senses anything. Oh, I forgot to make a closing bracket for this. Okay. And let's fix formatting, make sure everything's set up. Download to robot. Okay, yeah, seems to be no bugs. And okay, so it's sensing the line and it's turning. You can see the numbers that it's portraying here. Oh, okay, I think it might oh, okay. Just barely, I think. We need to make it a little faster for, let's just, instead of making it 60 so that it doesn't go forward at all, which might avoid us running into the cup. So once again, a lot of trial and error that comes into programming. So let's just download this to the robot, see how it does. Okay, obviously it's much more rudimentary. You see a lot of shaking because it's either going to be turning all the way to the left or all the way to the right. So this is going to actually, I believe this should finish up our, okay, it should finish the mission. Okay, nice. So what we can try to do is make this a little more efficient. Let's just speed this up, see how it does. Try to make this a little faster. Maybe 127 might be too fast for this, we'll see. I have a feeling 127 might be a little too fast, because as soon as it senses something less than 2000, it's going to make hard turns each time. Yep, it seems to have made it. Okay, and we can try to tinker a little bit with this side too. Let's call this 60. Download to robot. See how that goes. Right. So okay, yeah. Going much faster. So what we're able to see clearly here is that it's using the left side of the robot, right? It's using the left line follower. And it's basically using the sensor value. It's trying to see if this line follower will return a value that's less than 2000. So if it's less than 2000, it's gonna basically turn left and if it's not, it's going to turn right. So it's going to keep repeating this until it senses the value. So if it senses the line, it's going to turn to if it senses the line, it's going to turn to the right. And if it doesn't sense the line, it's going to turn to the left. So no matter what, on this course especially, it's going to be able to follow the line throughout the entire mission. So he's just following the line exactly. And you can monitor the values right here. So you can see, let's just start from the beginning. You can see that both the right and the left line followers are less. They're both less than 2000, but our code only uses the left line follower. So since the left line follower is less than 2000, it's gonna turn to the left. So if you see the start of our code, it automatically turns to the left. And then as soon as it hits that black line, it's gonna read as more than 2000, so it's gonna turn to the right. Okay, nice. Okay, so that's it for today. And we basically covered a little bit of sensors. And again, we completed another one of the challenges. If you go back to the home page, there is a Slalom 3. That one's a little more complicated. We're going to have to be a little bit more precise for the line following for that one. And you guys can go ahead and try to tackle that on your own. Okay.